The Underactuated Robotics Lab brings together different applied and fundamental research teams at DFKI to perform groundbreaking research in the field of underactuated robotics for dynamic robots such as brachiation robots or legged robots. Every year, we host a group of students from all over the world at our lab for internships and master theses. In this year, at the Summer of Underactuation, we had 9 students who presented their work, and most of them go forward and also publish their work in multiple conferences and journal publications. My name is Shubham Vyas. I'm a space robotics researcher here at DFKI, and I also lead the Underactuated Robotics Lab.
I'm working on developing control strategies to reduce the vertical motion of the robot center body when they navigate rigid surfaces.
I'm working on a control system for dynamic parkour motions on the hopping leg. And the hopping leg is able to hop around in a circle around the gantry, and I obstruct its way with some obstacles, and the goal is to overtake those and get to the finish.
At DFKI, my master thesis is about optimal control for satellites, so steering satellites as efficient as possible without hitting any obstacles.
I'm doing my master thesis here at DFKI. The project is about modeling the parallel continuum robot and to see how those flexible structures deform under forces.
At DFKI, I'm currently working on a symbolic library for code generation of the kinematics and dynamics of open-chain robots.
Despite all the amazing results which have been done in the last decades and also the more recent advancements in bipedal walking, there's still so much which we don't really comprehend and which we don't really work with right now, especially regarding hydrodynamic effects for underwater robotics. So I just find it exciting to feel like in a few years maybe we already made great advancements in this field, and I maybe can be part of it.
So nowadays it's common to see robots that can move around using wheels or robots that can walk around as well. They've become common, but it's quite rare to see a robot that can work like a monkey and brachiate across ladder bars, right? So that's what makes me passionate and fascinated about this project.
I'm fascinated about my project because double pendulum system is a highly nonlinear and chaotic system. It's very hard for classical control methods, but I'm trying to solve it with reinforcement learning-based control, which is state-of-the-art control method.
The most fascinating part about my work is that I can use my mathematical knowledge to combine it with real-world systems, which is the real motivation of studying math and applying it in real-world scenarios.
So the best day of my time here at DFKI was when DFKI sent me out to the European Space Agency in the Netherlands, where I was able to test my system, and then of course when the moment the controller showed it is working the first time, that was of course the best day.
So my best day at DFKI was when I signed my contract as research assistant, because it was open day at DFKI that day and there were all these robots around me, and I thought it was quite amazing to see them, and I felt at home.
Bremen is a very bike-friendly city. I can do everything by bike, and for my free time there are also a lot of opportunities. I found a sports club, I can go swimming in different places. Yeah, also with the Burger Park, that's a really big forest, so running there is perfect.
Bremen doesn't really lack anything this also great cities have, so it's really a surprisingly vibrant and lively city for it being rather small. So it's really exciting to live here. Yes.